Hi, welcome to ISE503, and this lecture is SQL Part 2, Structured Query Language Part 2, and the lecture slides are from our textbook, Principle of Database Management. So in this lecture, we will start the DML part of SQL, and here are these reference tables that we will be using. And the data is about the purchase order management system. Here we have these tables: the supplier table, the product table, supplies table, purchase order table, and the purchase order line table. So what we would learn, we will learn about SQL select statement, and we would learn about SQL insert statement, SQL delete statement, and SQL update statement. So these are the four statements that we would learn about in the DML part of SQL. DML stands for Data Manipulation Language. In the first part of Structured Query Language topic, we learned about DDL, that was Data Definition Language, where we learned about the create statement, and here we will spend time on select, insert, delete, and update. So these are the four statements of data manipulation language, or DML. So here is the overview. We will start with the simple queries, then we will look into the aggregate functions. That will be followed by the use of group by and having keywords. We will learn about the role of order by in an SQL statement. Then we would get into more interesting stuff involving joins, and up till I think these many topics I'll be able to cover. In this lecture. For the remaining topics, which are nested queries, correlated queries, and the remaining topic, I will have to record another video lecture. So let's start with a very basic general query using select. So these are the two keywords that we usually use, which is a must. These two are must in a select query. The first part is select, and then you have the component. So these components are actually the number of columns that we need in the resulting table. Number of columns. So select number of columns, and then in the second line we should use the keyword from, which is again the component. So this component is going to be one or more source table. So one thing that I should tell you right here about the DML statements in SQL. So in data manipulation language statements, we retrieve the data from existing tables. We can change the data in the existing table. Now the change of the data may happen by insertion of more record, or updating the data that we have there, or deleting the data as well. So in manipulation, or in the DML statement, we do the retrieval, update of the data, and then in the update you'll have the insertion as well as delete. Sometimes we also update the data that we have already in the tables. So back to a very simple SQL select query. You have select followed by component. Component you can treat as a placeholder or a kind of variable, which we could replace by the number of columns that we want in the output table that we get as a result of select. And yeah, from keyword is followed by the number of source tables from where we want the data. And these two statements are must. You cannot write a select statement or select query in SQL without using select and from. These two are mandatory keywords in a select statement. Now the third statement that you see here, let me put the number 3 for that, makes use of the where clause, and this where clause is followed by another component, which is often the predicate. Predicate means this part is true or false, right? So this part that you are looking at here is a predicate. Predicate means any statement which is either true or false. So this component could take shape of a comparison operator, and it may involve the use of in operator, and like operator, between operator. Well, I should be careful when I'm saying operator. I mean these simple, keywords that we can use after the where clause. And where is optional. You may or may not need a where statement in your select query. It all depends on the situation. With more examples, this thing will become more evident. The fourth statement that you're looking at is group by component again. So please don't be confused by this term component that you see in this example of a general select statement. Component is simply the placeholder. It can be replaced by some by some expressions or some column names, okay, that you'd see in more concrete example. Now you should have paid attention, or if not, then you can do that right now. Look at these square brackets, right? So we are using square brackets only for the third and fourth line of this statement. The reason being that inside the square brackets what we have is optional. Okay, so we would use where and group by in the select query only if they are required. These are not mandatory. Let's move on to another thing that we can add to select. This is number 5, having clause. So these are also referred to as clause, right? CLUSA clause, where clause of select statement, group by clause of select statement, having clause of a select statement. Okay, so we can also use having. You probably learn about having in more detail, but yeah, this is another thing that you can add to your query if you're writing a slightly complex query. Okay, and then I think there is one more thing remaining, which is order by. So let me put that as 6. So order by is also optional. We will use order by only if we want the result of the select statement to be presented based on ordering of a column. So we'll learn about that. So here what we learned, well, we just learned about some keywords that we will use with the select query. Okay, let's keep moving. So one interesting thing about the select statement is that the result of the SQL select statement is a multi-set, not a set, right? So this is important. We need to understand the difference between a multi-set and a normal set. So the select statement of SQL will return a multi-set. It's not going to return a set. So what is a multi-set? So multi-set is also often called as bag. The elements in the multi-set are not ordered and they can be duplicates. So that's the difference between a multi-set and a set. In set you cannot have duplicate items, whereas in case of multi-set you can have duplicate items. So the result of the select statement will return a table, and that table may have duplicate tuples. So let's look at some example of set and multi-set to make sure that we understand the difference between these two concepts. So the set here has 3 elements, 10, 5 and 20, whereas the multi-set that we have has what, 1, 2, 3, 4, 5, 6 elements. Out of these 6 elements, look at these. I mean, the element 10 is occurring 3 times, and whereas 20 is occurring once and 5 is occurring twice, right? So this is a multi-set, whereas here it's a set. In set we have unique elements, whereas in multi-set we can have duplicates. Now question arises, like why I think we did learn about the concept, this thing that a table is is a set of tuples. Okay, but in that, when we are saying set, then that means the tuple should be unique. At least that's what we learned in the relational data model. The relational data model says that in a relation, the tuples that we have, they should be unique. We cannot have them as duplicates. But in SQL select statement, we are learning that the select statement will return tuples, and these tuples may not be unique. Okay, so it will return a multi-set. Why so? So the answer to that is that SQL does not eliminate duplicates. Why? First of all, it is an expensive process, right? So why to do it if that is not always required? That's the message. Duplicate elimination is expensive, and the other interesting thing is that the user may want to see duplicate tuples, right? So what SQL has done, it will not remove the duplicates, and if the user wants to have unique tuples, then yeah, there's a keyword that the user will have to use, which is distinct. We'll learn about that. Distinct. Okay, so by default the duplicates are not removed, and first, because it is expensive process, and the second thing is that we may need those duplicates, and as I said, that there is a keyword distinct which we can use to enforce the uniqueness of the tuples. Now, question arises, why would user want to have duplicate tuples? So the answer to that is that duplicates may be considered by aggregate functions. We will learn about aggregate function, and in one of the example, you'd see that we may need the duplicate tuples in a result of the select statement. So these things are important. Make sure that you understand this fact about SQL select statement. Now let's get started, right? We would try to understand some very basic SQL queries, select statements. So here we go. Now SQL statement that retrieves the data from only one table, we are calling it simple. Simple means the data is coming from only one source table. When we would learn about the concept of join towards the end of this lecture, you realize that it is possible to get the data from multiple tables. And those queries, I'll say complex queries, because we will have the join operation. The queries that we will learn in the next few slides are simple queries because the source table is going to be one. That's the reason it is called simple query. So how do we write select statement? The keyword select followed by supplier number SUPNR, SUPNAME, SUP address, and subcity, substatus. Okay, so these are the 1, 2, 3, 4, 5. These are the 5 columns for which we need the data. And how do we get that? We'll say select followed by, we will list the name of these columns for which we need the data. And the data is coming from the supplier. So supplier is our source table. Okay, so the select statement is that simple. And as I already mentioned earlier, or probably I mentioned multiple times, one of the beauty of SQL is that it is declarative. You just tell what you need, and the query processor will take care of the rest. You don't need to specify navigational details. What you specify is what you need. So select keyword followed by the name of the columns, which are subnr, subname, subaddress, subcity, substatus. All these attributes or the columns are from the supplier table, right? So you say select all the column name, and then you will be using from keyword, because after from you need to specify the source table from where we are getting the data, and the source table is supplier. Okay. Now, if you remember, all these columns that we have, um, what I'm trying to say is that in this query Q1, all the columns that we have are the complete list of columns that are present in the supplier. Or in other words, in this query, we listed all the columns of the supplier table. So if that is the case, then SQL offers us a shorthand version of writing the same query. If you want the data for all the columns, you are not required to list them. If you want, you can, but that is a cumbersome process. Okay, just to save your time, what we can do, we can simply say select star. Star means all the columns. From where? From the supplier table. That's it. Okay, so the query Q1 version 1 can be written in version 2, and in version 2, in place of listing each column of the supplier table, we will simply put a star. We'll say select star from supplier. That's it. These are equivalent. And here, what will these query do? These queries will return all the data that we have in the supplier table. And this is the answer, right? So if we have, I would consider this as a only snapshot of the data that we have in supplier. But yeah, you can assume that we have 1, 2, 3, 4, 5, 6, only 6 suppliers. But in real life, it may be in thousands. Okay, so yeah, we got everything. We got the supplier number column data, supplier name, supplier address, supplier city, and supplier status. Okay, for all the tuples in the supplier table. Good. So now what you can do something which is called as projection. Projection means we want a subset of the columns, right? In the earlier query, we said select star from supplier because we wanted all the columns, but you may not be interested in all the columns. If that is the case, then we would do something called as projection, and the projection is very simple. What you have to do is you select, and then after that list those two columns for which you need the data. So our first column is sub number or sub NR, and the second one is sub name. So from the supplier table, we want the data only for these two columns, sub NR and sub name. Right? So that is projection, straightforward. Don't list all the columns, simply list the columns for which you need the data from table. And what will happen? The data from supplier table would be projected on these two columns. My bad. So the result from the supplier table would be projected on these two columns, which are sub NR and sub name. You should remember what is this projection thing, right? Yeah, projection means considering only some columns from the table for the result. So your result would look like this. Right now you have only two columns here, sub NR and sub name, and you're getting the data for all the tuples. So let's move on to the third query. Okay, here our source table is different. Here our source table is purchase order. Okay, and what do we need? We need only one column, that is supplier number. So we want all the supplier numbers from the purchase order. Okay, and here this is what you would get. All right, so we have the data for all the supplier numbers from the table purchase order. Now one thing I would like to highlight here is the fact that we have some duplicates, 32, 32. Then yeah, I think only two instances of 32. After that we have 37, 37, 37, 37, and 37. 1, 2, 3, 4, 5. 5 instances of 37. 2 instances of 32. And one instance of 68, one instance of 69, one instance of 94. So why did I do this thing? Well, just to give you this, just to use this example to highlight something that we learned. What is it? This is a multi-set. Okay, and this multi-set that you're looking at is the result of the SQL query that we have written here. So guys, sometimes I may use SQL for SQL, right? Earlier, SQL was called SQL, right? So it is very common. People may either say SQL or SQL, meaning the same thing. So for this query, that's our result, simple enough. But we should, understand the fact that this result is in fact a table, but this table is a multi-set. It's not a single, simple set. So how can, if we are not interested in duplicates, if we want only one copy of 32, 137, then 68, 69, 74, how to get that? It's even simpler. What? You say, you will put another keyword. You will put distinct before the supplier number. Alright, so the previous query that we had written would be modified, and we would include the keyword distinct. We'll say select distinct sub NR from purchase order. Okay, and the result would be this one, and this is in fact a set. Okay, so yeah, it's simple enough, but yeah, please do remember the minor difference between a query without distinct and a query with distinct. Select query with and without distinct. Now let's see what we have in the next query. This is our query number 5. Here, okay, so select is followed by these 3 columns, right? Supplier number is our column number 1, product number is column number 2, prod NR or sub NR, and then the third column that we are interested in is delivery period. Okay, and well, this part I have missed for intentionally. I'll get to that later. I'm missing this part also, so this thing I will discuss later. Let's first do the simple thing first. Okay, we want the data for sub NR and prod NR and delivery period, and all this data is coming from our source table, which is supplies, right? So from this supplies table we want the data for these 3 columns: sub NR, product NR, prod NR, and delivery period. Good, simple. Probably we are using supplies table for the first time in this lecture, right? Good. So now let's look at more interesting stuff which will make this query slightly complex. We are not using the actual column delivery period. Rather, we want a value which is derived. Okay, derived value from an existing column. So delivery period, DELIV, deliv period, is a column in the supplies table, but we don't want the data as it is present there. The data is probably the data has the unit in days, but we don't want to mention the delivery period in days. We want it to be mentioned in months. Okay, so for that reason what we are doing, we are saying, okay, fine, on that column delivery period, let's do this computation, which is division by 30. Okay, so if you divide that column by 30, then the number of days would be then the delivery period would be reported in number of months in place of number of days. Good, fine. So if you follow that, then now let's pay attention on as and this part, right? So as and monthly, month, deliv, sorry, my bad, DLIV, deliv period. So this part, right, what is the purpose of using keyword as? So this computation that we have done here, which is deliv period divided by 30, is given a new name. What is this new name? New name is over here. So the result that you will get will have 3 columns. The first column would be sub NR, the second column would be prod NR, and the third column will have a new name here, which is month deliv period. So the role of this keyword as is for giving the name to a result, and this is also sometimes called as aliasing. Aliasing means giving a new name, right? So it's very common. Very soon you will see that we will use the keyword as more often, because we would need to rename tables as well. Good, fine. Let's keep moving. Okay, sorry, my bad. I'll have to erase this clutter so that you could see the result. The result of this query is over here in the table that you're looking at. The data for this table is coming from the supplies table, and this resulting table has these 3 columns: sub NR, prod NR, and month deliv period. Okay, and these are the tuples. Interesting. Fine. Now we will learn about another very important, which is in fact optional, clause in select statement, that is a where clause. All right. So all the queries that I have written till now, we did not impose any restriction on the row. We wanted all the rows, right? But sometimes you may not be interested in all the rows from the table. You may like to impose a condition on the row, and you may only want to get the rows that satisfy the condition. Okay, so wherever we have to apply the condition, we will wait a second, right? I should be careful about it. When we want to impose the condition on individual rows, right? So keyword over here is individual rows, individual rows of the table, of a table. We will make use of the keyword where, and the keyword where is followed by a condition. Okay, so we will get to that maybe in few seconds. Let me first read the whole query. So we are interested in supplier number, so you say select sub nr, sub name from supplier, right? So this is the source table. Source table is supplier, and from supplier source table we are doing a projection on the sub nr column and sub name column. Okay, so this part here, let me put that in a circular curve kind of thing. This is projection. Okay, and here we are learning one more operation using the where clause. This operation is called filtration. Filter, right? We are filtering the table, and we want only those rows from our table that would satisfy the condition. What is the condition? Condition simply says that we want the supplier number and supplier name only for those suppliers who are in San Francisco, right? So the where clause or the where is followed by this condition, which is based on the subcity column of the supplier table. Okay, so we'll say where subcity is equal to San Francisco. And this process of putting a condition after where is called filtration, whereas projection we have already seen. And your result would look like this. Okay, from our table, supplier, there are only these two suppliers, Best Wines and the Wine Depot, who are from San Francisco. Right, let me see if I could get this table. No. Okay, that might be somewhere, but you can figure it out, right? I'll share the lecture slides with you and you can cross check, or if you have the textbook, even better. Good, let's keep moving and see what do we have in the query number 7. In query number 7, we are doing projection on supplier number and supplier name, similar to the previous query. Okay, so select sub and R sub name from supplier, very similar, where supplier city is San Francisco. We already did that. Now you know what? We are making use of AND operator, logical AND. So I am not going to the details of AND operator and OR operator. If you need any help, please reach out to me. I'm assuming that you already know about AND and OR operator because these are very basic concepts in any programming. Okay, so our where clause that we have here needs to be correct and needs to be true for these two statements. What is it? Well, the row that we are interested in the result should have the supplier city or subcity as San Francisco, and at the same time the supply status, substatus of that supplier should be greater than 80. Okay, now we have two conditions here. Condition number 1, which is based on supply city column, and condition number 2, which is based on supply status. Okay, it is very common and it is very practical where we may have to impose more than one condition in the where clause. And your result would be this. Right now we have only one supplier, Best Wines, that is in San Francisco, and has status greater than 80. In our earlier query, if I could recollect, we had, let me see, we had two suppliers, the Wine Depot also, but their status, if you can see, the status of the Wine Depot is 10. Now you know here we have a typo. the typo is that we should say select supplier number, supplier name, and sub status, right? So let me add that sub status. Why? Because we are getting the result for the sub status column as well, but in our select we have only two columns, right? So this is a typo. I'm sorry about that. Good. Here again we have the same problem. We should say sub status as well. We need the result for supplier number, sub NR, sub name, and sub status from supplier, where the conditions are the sub city is San Francisco and sub status is greater than 80. Let's look at the query number 8. Now query number 8 is selecting or projecting the supplier table from, right? We are getting the data from, and the select is followed by these columns: supplier number, supplier name, supplier status from supplier, where sub status between 70 and 80, right? So here we are making use of the where the between keyword. Okay, what will this between do? Well, this between will return only those suppliers in our result where their status is either 70 or 80 or in between 70 and 80. Okay, so one thing that you need to keep in mind is that this between thing is checking for the value in between 70 and 80, including these boundary values. So these boundary values 70 and 80 are included in between. All right, so let's summarize that. This query number 8 will return the data from supplier table with the column sub NR, sub name, sub status, but it will return this data only for those suppliers where sub status is in between 70 and 80. Okay, so for me this is slightly easier because I already have the query in front of me and I have practiced it multiple times before delivering this lecture. But when you're preparing for the exam, you may have the questions in English, right? And you'll have to do the reverse of what I am doing. Okay, given a query in English, you'll have to come up with the SQL query. Okay, so for you need a lot of practice. Here is the result. Okay, so the wine crate is the supplier with the supplier number 94 and supplier status 75, and look at it, 75 is in between 70 and 80. This between would be interesting and important. That's the reason I have put multiple stars on top of that. Well, let's continue and learn about one additional keyword, in. Okay, so let me first read the query just to get some context, and then I'll explain to you the role of this keyword in this specific selection statement. It says select prod NR, prod name from product. Okay, so this whole query is considering product as the source table. From the product source table, we need the data for these two columns, which are prod NR and prod name. But we want this only on a condition, and the condition is always specified after the where clause. Okay, so we'll say select prod NR, prod name from product where prod type in. Now this is going to be interesting, and I will explain to you why is it interesting. So in order to explain it to you, I will rewrite this query, okay, in simple words. Okay, it's not, I should be, I think this is not symbol. Okay, not equal to, right? Probably this is what we use for not equal to, as far as I remember. Now the same query can be written as equivalent, right? Or select prod NR, prod name from ROM, my bad, let me erase. Okay. Take few minutes, few seconds. From product where okay, where prod type uh, no equal to, I think we don't need not, right? So sorry about that, we won't need not in this case. This equal sign is good, where prod type equals white or, right, prod type equal to sparkling. Sparkling. All right, that is an equivalent query, right? But as you might have noticed that I had to write more, right? Here I had to write a little more in comparison to what we have over here. So I'll prefer this version because this is more readable and it will save some space also. Okay, so these two are equivalent. So probably you got the meaning of in. Okay, so what it does when you're saying where prod type in white sparkling, it means that we are interested in the product number or product NR and product name of only those products whose type is either white or sparkling. Okay, if you want you can add more conditions over here, but it is straightforward, right? So that is the usage of, or that's the meaning of the in clause, right? We use in with the where clause. Okay, and I remember we also used this in the earlier lecture when I had some constraints, right, in the definition of probably the domain we use in, and it was also used in one of the tables creation, I think, create statement. Excuse me. Okay, the same issue. I did not realize that there is a table with the results, so I will quickly erase this, the clutter or the stuff that I had written to reveal the table with the result. Okay, so this is the result, okay, which you will get uh, from this query. Okay, so what do we have next? Well, we have another interesting thing. So if you're paying attention, then all these queries that we are learning for the past few minutes, they're all trying different ways of using the where clause. All right, so this where clause is changing in every example of the select statement. Fine. So what is the select statement trying to do? Well, the select statement is getting the data from product, right? We have seen a lot of queries by now. This is our 10th query, and we are kind of having some understanding of the role of each of these clause. Okay, like select is followed by the columns that we need in the result table. Therefore, we need prod nr and prod name, and this data is coming from product. Select prod nr and prod name, comma prod name from product. So this data is coming from product. We want the data for only these two columns. Now, whenever we have a where clause, then where clause will impose some restrictions on the rows, okay, from the source table product. So here the condition is based on prod name, the product name. Okay, so condition has been written like this, where prod name like, right? So this like is also very interesting keyword. What it does is it compares these strings. All right, so prod name is the name of a product of the product, and that will be a string value. Now we want the result, which means the prod nr and prod name only for those products where the name has the substring char. All right, now what we are doing here, we are using some wildcard, right? So wildcards are very popular in pattern matching. That's what we are doing here. We want the prod number, prod nr, and prod name for those products from the product table where their name has the substring char in there. Okay, and let's try to understand the role of these percentage symbols that we have in the beginning and at the end of this chart string. Well, the role of this percentage is to match one or more than one character. Okay, fine. So your result would be like this. If you run this query, you'll get the product number, product name, and all these products, they have their name that has chart in there. Here, chart here, chart here, chart here. That's the reason you would get these four rows from the product table. Now, it is also common to use the underscore, right? So the underscore is also substituted in this kind of query with like, but if you're using underscore, then it will substitute only for single character, right? So here we said multiple character, one or more. Okay, so that's the difference. Fine, let's see what we have in this query number 11. Query number 11 is saying select sub NR, sub name, sub status from table supplier where sub status is null. That's an interesting thing. Okay, so why is it important? Why is it interesting? First of all, this is the first time when we are using the keyword is null. Where? In the where clause. Okay, this is the first time when we are making use of is null in the where clause. And what are we checking here? We are simply checking if the value of substatus is null. All right, so null is a very interesting value in the table which can mean multiple things, right? So it is not a value. This is something we need to understand. Null is kind of a placeholder, it's not a value. Okay, so for some columns we allow the column to have null values, for others we may not, right? So it all depends on how did we define the table. It all depends on how we created the table. If the create table had the column declared as not null, then yeah, we cannot have a null value there. So the primary keys and the candidate keys, they often will have this constraint not null. But if there is a column where null values is allowed, then we might like to see the supplier whose status is null. If that's the case, then we'll simply say where substatus is done, right? Checking like this, wait a second. If in place of that, if in place of this thing, right, if I try doing this, I say where substatus null, then this is wrong. Okay, null is not a value, therefore we should not equate the column name with the value null, right? Because it's not a value, it has very interesting interpretation. Therefore it is recommended that you use is null or is not null. Okay, is not null is also used. So the result is the supplier Spirit and Co. The status is null, right? Good. It is an important query. Okay. Now, what we would learn now? Well, we already have seen what 11 queries. Yes, 11 select statements. We changed these statements from. We started with very simple query. With all the columns, then we use star, and then we use project. In project, we were interested in only some columns from all the columns of the table. Then we introduced the where clause. In the where clause, we looked at all the different kinds of operators or the clause that you can use with where, involving between, in, like. Okay, now let's move on and learn a new and interesting thing, which is aggregate function. Okay, so there are some functions provided by SQL which we can use to perform some computation or summarization on the data of the table on some columns. Okay, so these functions are count, sum, AVG is for average, variance is a simple statistical variance thing, min and max, minimum value, maximum value, and standard deviation. Okay, so these are 1, 2, 3, 4, 5, 6, and 7. These are 7 aggregate functions. This is very important, guys, for quiz kind of test, that you know about aggregate functions. Okay, and these are one more time: count, sum, avg, variance, min, max, and std diff. We will be using this table for the reference, and this table is about supplies, I think. Yes, it is. The table is supplies. How did I guess? Well, because here there are two foreign keys, sup nr and prod nr, and supplies is a table which implements the relationship between the supplier table and the uh, product table. Okay, so prod nr and sub nr and prod nr are the two foreign keys. Combined together, they will form the primary key. And the other two columns are the purchase price and the delivery price. So if we have a supplier who's supplying a product, then yeah, we want to know what is the purchase price for that product and what is the delivery period. Good. So now let's use the very first aggregate function, which is count. All right, and this query simply says select count star from supplies where product number is 0178. Good. So how to understand this query? Well, it all depends how you do it, but the way I do is I will first see what we are selecting. So here the result is an aggregate function, count. So what count does? Count will count the number of rows returned in the result. Okay, so here we want the number of rows which are being returned by this query. Okay, what is the query? The query is simply selecting from a supplies table the records where the prod nr is 0178. So let's go back, 0178. So these are my pen, 1, 2, 3, 4, 5. So in fact, all the rows that you're looking at correspond to the product number 0178. Okay, so we want to find how many rows do we have corresponding to this product number 0178. So for that, what we would say, we would simply say select count star from supply where prod nr is 0178. Okay, so if I remove the where clause, then it will count all the rows that we have in the supplies table. But since we have put a where condition, so we are getting now the count of the number of rows that are related with the product number, which is 0178. Right, simple enough. Let's move on to the next query number 30, which is also making use of the count only. Okay, and here we say select count purchase price from supplies where prod nr is 0178. Right, so purchase price, earlier we were counting all the rows, right? But here in the query number 13, we are more specific, right? We want to count the purchase prices available for the product with the product number 0178 in supplies table. So I'll take you back to this here. Here we want to count these prices, right? We are counting purchase price for the product is 0178. So this count is happening on this data. Okay, so one thing that you will have to understand is that for count, null is ignored, right? Because for here we don't have the purchase price, so we should not consider null as a count. Okay, so we will ignore, and the result would be 1, 2, 3, and 4. There are 4 prices available, okay, for purchase price. So therefore this query which says select count purchase price from supplies where product number of product nr is 0178, here the result should be 4. Good. Now, well, if I take you back, then you notice that the we have these duplicate values, right? The prices are duplicate because there are two suppliers One supplier with supplier number 37, the other one is for 69. They are both supplying the product to 0178 with the same price, whereas supplier 68 and supplier 97, they have different price. Okay, so here in this count, right, it will count this value is 16.99 twice. Okay, if you want it to be counted only one, then for that you will have to use the keyword distinct. When you say select count distinct purchase price, then yeah, it will be 3 purchase price from suppliers where prod number is 0178. Okay, good. Yeah. Now we will learn about the second, aggregate function, which is sum. What it will do, as it is evident, the sum will add the values. So let's look at this query to understand the role of this sum aggregate function. We are saying select prod and R sum quantity as some orders from PO line. Now our table is different. This data is coming from purchase order line table or PO line. What we need product number, prod NR, and the sum of quantity. Okay, so okay, some, and we are giving it a name. So this computation, which is sum of this quantity column, as we will compute that sum, we'll give it a name. The name is sum orders, right? So using aliasing, we are giving the name to this summation that we are doing. We're calling it sum orders. And this data is coming from PO line, the table purchase order line. And the condition is where the product number is 0178. So what we want from this table purchase order line, we want to find out how many how much of this product has been requested or ordered, right? The quantity column has that thing, but we want to sum it up because we want to count this total quantity for one product with the product number 0178. How to do that? Simple, apply the sum aggregate function. Therefore, the result of this query would be, this is the PO line table. With our interest, we are interested in these two rows only because these two rows correspond to the product with product number 0178, right? So this will be added up. 6 plus 3 is 9, right? That should be our result. So our result has product number, we want product number, and the sum of the quantity, some quantity. But this expression, when you're doing sum, should be given a name. What's the name? The name is sum orders. Okay, so yeah, that's the result. It's important. Okay, so you should be able to use these functions, right? So the questions the question may not explicitly say that you have to use this aggregate function. You need to figure it out from the English query. Okay, so that's where you'll have to practice. What do we have next? Another example of the sum. So here we are saying select sum quantity as total orders from purchase order line. So here we don't have a where clause. In the earlier query we had a where clause, right? So we are lifting this restriction. In the query number 15 we were interested in finding out and summing up the quantity for the product with product number 0178. But in the query number 16 we lifted that restriction. Okay, our source table is same. We want we say select some quantity as total orders from PO line, okay, which is 173. Good. So we learned about the aggregate functions. There are a few more aggregate functions. They are simple, very simple. You can use them. Now in this query number 17, we have some interesting thing. Let's see what we have. We are saying select. Okay, fine. We are doing average, right? AVG we did not try yet. So the aggregate functions that have been used till now where we started with count and then sum. Now let's look at the AVG, which is for average. Okay, and we are using this table as a reference table because the data is coming from supplies, right? Look for from clause will be followed by the source table. Good. So to the query, what is the query saying? Select prod nr. Yeah, we have that column here. Average of or avg of purchase price. Here is the purchase price, right? We want the data for product number, average of the purchase price. We will call that as weighted average price. I'll tell you why we are calling it weighted. This data is coming from supplies table where prod nr is 0178. So we are putting that restriction again. We are interested in finding out the average price for this product number 0178. How to do it? Simply apply this AVG aggregate function on the column purchase price. Okay, and we want to give that this computation a name, right? So this computation is being called weighted AVG price, weighted AVG price, right? So now how is this computation done? That is explained over here. So when we are saying that we want the average on the purchase price, then this price will be ignored in this average computation. We will consider 16.99, 17.99, and 16.99 one more time, and 18.00. Okay, so we are considering these four values. We exclude the null. Okay, and here the average would be, just sum it up, divide by 4, simple. Now this value that we are computing is basically a weighted average. Why weighted average? Because we had two instances of 16.99 and those both the instances were included in the comparison of weight, sorry, of the average. Okay, so effectively this whole thing can be written as 2 times 16.99 plus 17.99 plus 18.00 divided by 2 plus 1 plus 1, which is what? This is simply the weighted average. These are the weights, right? So that's why we are saying it's a weighted average. If you want the normal average, then for that you'll have to consider only one instance of 16.99 and you will divide the whole, you will add 16.99 plus 17.99 plus 18.00 divided by 3, which will be your real, the actual average. Now question arises how to do that. Well, if you're interested in that, then yeah, in place of the average purchase price, you will have to insert a distinct there inside the parenthesis. Okay, so that's what you have in the next slide. We say select prod nr average avg distinct purchase price as unweighted average price from supplies where prod nr is 0178. Okay, and look at this computation. 0178 would be reported because that's the first thing that we are requesting in the project. We are saying select prod nr and followed by this thing, which is 16.99 plus 17.99 plus 18.00 divided by 3, which is 17.66. So the difference between the weighted average and the unweighted average would be interesting here, and more so from the SQL point of view, where you'll have to understand the role of the keyword distinct here. And the next query that we have, which is query number 19, here we are making use of the variance aggregate function. We want the variance of the purchase price from supplies table. Okay, so we will say select prod nr variance purchase price as price variance from supplies where prod nr is 0178. Well, let's use the two more functions, aggregate functions provided by SQL. Min and max, straightforward, right? So here we will say select, this is our query number 20, select prod nr min purchase price as lowest price, we are giving it a name, max purchase price as highest price from suppliers, and we want this data for the product number 0178. And look at the result. It has 4 columns. Product number 0178. The statistics that we have is for product with the product number 0178. Its lowest price is the next column that we have here. We have given it the name as lowest price, which is computed by using the min aggregate function on purchase price. And the last column that we have, highest price, is being computed on the column purchase price by applying the max aggregate function. Good. And this whole thing is done for the product with product number 0178. Good. So now what we will do, we'll move on to another very interesting clause which is used for writing slightly more complex query, group by. And very often this group by is used along with the having clause. So these two clauses are used together most of the times. Okay, so let's see what group by will do. So let me see if the query that we have here is going to help me out in explaining the group by. Okay, here we want to select product number from PO line, group by prod NR having count star greater than or equal to 3. Good. So this query is interesting, slightly difficult I would say as of now. Without any background, right? So let me give you some context and let me give you some idea about group by. All right, so we have learned about the aggregate function. Here we are using the count. So if I say select count star from prod nr, okay, so simple query, if I say select count star from PO line, then what will happen? We can count, right? I mean, although this count is not complete because we have some bullets here, meaning that there are so many other records that we don't know about, right? So let's assume that there are 500 records. If there are 500 records here in PO line, then the result of this query would be 500. Good. So why did I write this simple query? Just to tell you that if we use an aggregate function like the way we have done here in this query, then this aggregate function is applicable to whole of this table, right? You may have some filtration using a where clause, but after that you are doing this computation on the result of the filtration. Good. But often it's very important to do this kind of aggregate function, apply these aggregate function on some groups of the table, right? So the purpose of doing group by is to group the data which is available to us or group the table available to us based on some columns, right? If the column value is similar, then we would like to group those records together, right? So that's what is done in group by. So in this query, let's see how much we can understand. Select prod nr, right? Good. From PO line, so this is purchase order line, and PO nr is one of the column over here. Prod nr, sorry about that, not PO nr, we want prod nr. PONR is purchase order number and prod NR is product number. Okay, so we want to select product number from this table, which is PO line, but after that we are saying group by prod NR. So what will happen by grouping by? We will conceptually put all the records with similar product number at one place, and that's how we will form a grouping, right? So let me see this one 0212. How many of 0212 we have? 2 and 3. Okay, so these three records would be grouped together by group by. Why? Because they have the similar value of the product number. We are doing grouping by prod number. It depends on your column. You may use a different column also. Like PO and R can also be used for grouping. So group by may be followed by PO and R, but that will be a different query. Okay. So here in this query, we are grouping by prod and R. So this is one group. Call it group number 1. Similarly, you would look for 0178. 0178 has only, okay, it has two values, right? 0178, 0178. It is yours second group, 0178, right? Similarly, you will be able to find out a group with 0900. Okay, this is group 3. So that's precisely what we will do. For each product number, we'll form a grouping. And after this grouping is done, this aggregate function is now applied on these individual groups. Okay, so this count star that we are doing, in this count star, we are counting how many, you know, tuples do we have, rows do we have in each of the group. Right, for 0 to 1 2, there are three records with the product number 0 to 1 2. Similarly, for 0900, there are three of those. For others like 0178, there are only two. Okay, now if you follow, then let's put that thing in this query and try to understand. When we say select prod number or select prod NR from PO line, group by prod NR having, now this having is interesting, I'll come to having later, having count star greater than or equal to 3. So this having is similar to where clause. It is similar, right? So having, we are making use of having clause to do something very similar to where clause. What we did in where clause was used to select, or I should not use select over here because select is used in multiple, in other context as well. Filter out, right? So after the where clause, we had a condition, and using the where clause, we were filtering out some of the rows based on the condition specified after the where clause. Okay, we are kind of doing the same thing here as well, but here our filtration is done after the grouping. Okay, so the where clause is followed by an aggregate function, always an aggregate function. Okay, that's the difference. The having clause does a filtration similar to the where clause, but the filtration is done on the result of the aggregate function. Okay, whereas in case of a where clause, the filtration is done on the individual records. All right, without any aggregate function kind of thing. Fine. So what is our query doing here? Our query is returning the product number from the purchase order line, where this product number has been listed 3 times or more than 3 times, right? So that's what we achieve by grouping by product number and then applying a having on the count star. Okay, good. So in order to illustrate what is going on, we can look at this picture. So what do we have in this picture? Let me put some number: 1 2 3 4 and 5. Why did I put these numbers? Well, because these smaller tables that you're looking at, these tables are representing grouping, right? And in this group, look at these the product NR value. In the first one, which is marked as 1, the product number is 0212, and there are 3 entries for this product number in that group. In the second group, prod NR is 0178, and there are only 2 values in the second table with that product number. In the third one, similar to the second, product number has only 2 entries. It is 0668. That's the product number. In the fourth group, there are 3 entries, and this group corresponds to the product number 0900. Okay, and in the first group, we have only 1 entry that corresponds to product number 0185. Okay, and our requirement is that this number should be greater than or equal to 3. Therefore, only the first one and the fourth one satisfy the requirement. Therefore, our result is product NR 0212 and 900. Okay, so guys, this query is very important. Okay, this one here and this query over here, very important. So in fact, the concept of group Y and having is very important. You need to understand the difference between having and the where clause. Good. Let's keep moving and learn about this group by taking another example. In this query, which is our query number 22, we want to select, or we want the column with product NR and sum of quantity, which we will call as quantity from PO line. It's our same table. Group by prod NR, right? Similar to the previous query, we are doing grouping by, and this group by is being done on the product NR, right? Similar to the way we did in the earlier query. But here the condition is slightly different. We are making use of the having clause, and having is followed by the aggregate function, which is sum. In the previous query, we used the aggregate function count, but here we are using sum. Sum on what? The quantity. And here the requirement is that the sum of the quantity should be greater than 15. Okay, so here again the grouping is being performed. You have the first group with the product number 0212. You sum the quantity because here the aggregate function is sum, right? So if you add these numbers, 15 plus 6 plus 2, the result is 23. In the second grouping, on the product number 0178, 3 plus, there are two rows for the product number 0178. If you add the quantities 3 and 6, it is 9. In the third group, we have the product number 0668, quantity 7 and 9. If you add that up, it is 16, right? And similarly, for the remaining two groups, when you add the quantity, it is coming out to 2 and 14. Our condition says that the sum of the quantity should be greater than 15. For that, only this product number 0212 and the product number 0668 satisfy that. Right? 23 and 16 greater than 15. So the result is over here. Product number and quantity 0212 has 23 and 0668 has 16. Another interesting and an important query using group by and having. Okay, now let's learn about a slightly simpler clause, which is order by. What order by does? Order by is used in presenting the result sorted by one of the column or more than one column. Okay, so let's look at this query to understand the role of order by. We want the data for purchase order number PONR, PO date, sub NR from purchase order. Okay, so we have this table purchase order and it has these columns of purchase order number, that is its primary key, purchase order date, PO date, and sub NR. Sub NR is the foreign key. Anyway, now if you look at the statements, we don't have any where clause, we don't have any group by, we don't have any having clause. So till this point, it's a very simple query. Why? See, we haven't, we did not discuss join. Probably in the next few slides, we will start that as well. But this query, if you consider only these two rows, is very simple. We want the data in the column PONR, PO date, sub NR from purchase order, right? Good. So it will be displayed if you only consider these two lines. But you know what? You can arrange this the result in some ascending or descending order based on one or more than one column, and that is achieved by order by. So the last row here in the select query says order by what? PO date, which is purchase order date, ascending order. ASC means ascending order. And after that, if by some by chance, if we have more than one record or more than one row with a similar PO date, right, then we will resolve that thing by doing another secondary sorting on the second attribute, which is sub NR. And in sub using sub NR, our sorting would be in the descending order. I think it's probably one of the simplest clause that you will learn in DML. Order by. You have to sort the data. You may sort the data in ascending order. If that's the case, then you say order by the name of the attribute or name of the column that you want to use for sorting, and that column name which you want to consider for sorting, and then you have to specify the order. Is it going to be ascending on this column value, or is it going to be descending? Here in this query, we are doing two sorting. First sorting, which you can call as the primary sorting, is done on PO date. It is ascending. And then the secondary sorting is on sub NR, that is descending. Okay, and here is the result. Alright, so if you look at the PO date, then yes, we don't have two records with the same PO date. In fact, this is in the increasing order or the ascending order, because the first date is the March of 24th of March 2015, then the next is 10th of April 2015, then 11th of April 2015, 12th of April, right? So in fact, the PO date is enough for this snapshot of the data that you're looking at. All right, if there was a tie, then the supplier number would be used to further sort the data in the descending order of the supplier number. So guys, often group by and order by are confused, so you should understand the difference between group by and order by. Very different. Okay, group by is required to form a group, and then after forming a group you can apply the aggregate function, and then can apply a having clause on that. Whereas order by doesn't do much, right? It is only useful in representing the data in ascending or a descending order based on one or more than one columns in the resulting table. Fine, let's look at few more examples, one more at least. Here we are looking at order by. We want what? Select prod NR, sub NR, purchase price from supplies where prod NR is 0178, order by 3 descent. So now this 3 could be tricky, but don't worry about this 3. This 3 simply refers to the third column, which is purchase price, right? So this very simple query wants to display the data from supplies table for the product, which is product number 0178, and here we want the columns product NR, sub NR, purchase price, but this data should be presented in the descending order of purchase price, something like this. Okay, excuse me, let's keep moving. Now, very important thing, right? Probably the last part of this lecture is join, and in the join we will learn about inner join and the outer join. So we will use these two tables for our discussions or for our illustrations. So let's make sure that we understand these two tables. So on the top we are looking at the relation, supplier relation and supplies relation. Supplier relation has the primary key, which is sub NR, then we have the column sub name all the way till sub status. In supplies relation, we have the primary key, which is composite one, with sub NR and prod NR as the two columns, and sub NR is a foreign key. As you can see, it is getting the value from sub NR of supplier. Then we have the prod NR column, which is again a foreign key. It's getting the value from prod NR, primary key of the product. Then we have the column as purchase price. Good. So on the top we have the relations. On the bottom you are looking at the corresponding table, table 1 and table 2. Table 1 refers to the supplier relation, okay, whereas the table 2 has the data from, or corresponds to, let me say the table 2 corresponds to the supplies relation. Good. All right, so now let's move on to the join. What is inner join? Okay, so well, we will go to that, but let's see what we have in the query, because anyway I would need the queries to explain to you the concept of joins. So here what do we have? Select wait, right here I should start from this point. Well, I can start from the bottom, the top also, and then in the next, first I'll read it from the top, and then in the second reading I'll start from the bottom to explain what's going on. So the query says select r.subnr, r.subname, r.substatus, s.subnr, s.prodnr, s.purchaseprice from supplier R supplies S. Good. Now, this is probably the first time when you are looking at a query with the period there. Okay. Now, the period is a very useful symbol that we use in SQL, and it is used for something called as qualifying. What is this qualifying? Well, we qualify each column with its table. Okay. So why is this required? For that, I'll take you back to this slide. Okay. Well, in table 1 and table 2, look at this column, sub NR, sub NR, right? So in fact, we have a column named sub NR in supplier table, and we also have sub NR column in the supplies table. Okay, so it is common that you may have two tables with the same column name. This will happen. This is very practical, and you can see it's happening in this picture. So whenever we have the columns with the same name in two different tables, then we want to somehow disambiguate it, right? It's an ambiguity. If I say sub NR, then the question arises, which sub NR I am referring to. Is it the sub NR from supplier table, or is it the sub NR from supplies table, right? So in order to distinguish this thing, we need to attach the table name to the column. How's that done? That's what we are doing over here. Okay, so for that explanation, now I will start bottom up. Why? From, we should know the source table. Okay, so what is being done in this query, we are giving a name to each table. The question arises, is that required? I say no, it's not required. In place of r.sub nr, you may simply say supplier.sub nr and supplier.subname, supplier.substatus. But that will become a very cumbersome query. Okay, just to make your life easier, you may like to give the variable name to these tables. That's precisely what we are doing here. When you say from supplier, then after saying from supplier, you'll give a name to it, which is R. Okay, so from supplier, we'll refer to that as R. Supplies, we'll call that as S. Okay, so these are the variables given to these two tables, or aliasing in a way you can say. So in this query, R refers to supplier table, S refers to supplies table. Right? If you're wondering why R and S, look at these two tables. Their name is very similar until the last character, right? This is where these two tables' name is different, right? So supplier, the last character is R. For supplies, last character is S. Other than the last characters, these are same. Okay, that's the reason they are called R and S. Fine. So if you understand from thing, then yeah, you can come over here. Just select r.subnr, which means the subnr from the supplier, r.subname, which is a subname from the supplier, R.substate means substatus, means the substatus of the supplier. S.subNR means the subNR from supplies. S.prodNR means prodNR from supplies. S.purchase price means purchase price from supplies, right? Good. The query is simple, right? And you will run this query. And after running this query, you will find something very, very interesting, right? Something like this. Okay. So the result would have all these columns that we requested for: supplier number, supplier name, supplier status, supply number again, supplies dot product number, and the purchase price. Good. If you look at this table carefully, then you would be okay with this combination, because in this first row, the r dot sub nr is matching s dot sub nr, right? So this is fine. We would like it, right? Whereas if you look at the second, probably it doesn't look good, because the supplier number which we have from the supplier table is not matching the supplier number from supplies, right? So this is not good. Okay, similarly 37 versus 21, this is not good. Okay, so if you look at every row from this table, you realize that most of the combinations which are provided in this table, they are not matching properly. Matching means the supplier number should be same, otherwise it is meaningless, right? So what has happened here in this result is called the Cartesian product. Okay, so in the Cartesian product, what happens from the two tables, like these tables supplier and supplies, all the possible combination of the tuples have been generated, and most of those are meaningless because their common columns values are not matching. Okay, so this is the Cartesian product. So here this whole query that we have corresponds to Cartesian product. And in the Cartesian product, as I mentioned, from the two tables, here we have only two tables, the tuples are combined in every possible values, every possible not values, I should say, every possible ways to generate the final tuple. Okay, and a lot of tuples that you get in the final table are meaningless because they are not matched properly. So we need to match those properly. Okay, and how to match those properly? Simple. We have to impose a condition, right? And how do we impose the condition? We will use a where clause, and that will become our inner join. Okay, so that's where we are going. Fine, inner join, right? So till this point, let me put a box around this thing, right, which we have already seen. We already discussed it, right? Which is R Cartesian product S. I don't want to write too much, so I just wrote R multiplied by S, which is the supplier table Cartesian product supplies table. Okay, which we don't want, that is useless. Okay, so what do we need to do is we need to add one more clause over here, one more line here, which will do the proper matching. Right, from this Cartesian product that has been generated, we want only those tables where the supplier number from the supplier is matching the supplier number from supplies, right? And this where clause is converting this Cartesian product to inner join. That's inner join. Very, very important. Okay, and that's how we write the inner join. Good. Here we have two source tables, supplier R and supplies S, and we are joining them. Joining means we are providing the condition which is provided over here in the where R dot sub nr is equal to S dot sub nr. So this sub nr that you have on the left hand side corresponds to the primary key of the supplier table, and sub nr that you have on the right hand side corresponds to the foreign key column of the supplies table. Good. So yeah, if you look at this table now, this one and this column, they are perfectly in agreement with each other. Okay, and that's what we actually need. We need inner join. Let's look at some example of inner joins. And in fact, I will tell you one more way of writing inner join. But before that, I should tell you that whenever we do a join like this, then this is called implicit join. Implicit join. Why implicit join? Because although we are doing a join, but we did not use the word join anywhere. That's the reason it is called implicit join. Very simple to write. Whereas it is also possible to do this thing using explicit join. Guys, you need to remember these things, right? These things may not be there in my lecture notes, but yeah, I'm discussing that in the video lectures. So yeah, please watch video lectures. Good. So the same query that we had written earlier can be written this way. Query number 27, which says select r.subnr, r.subname, r.substatus, s.prodnr, s.purchase price from supplier as r inner join. Look at it, right? That's the explicit thing. We are making use of the keyword inner join. Inner join with what? Supplies as s. Okay, on r dot sub nr is equal to s dot sub nr. Okay, so well, I would leave you people to work it out. It's extremely simple. This is syntax issue. Okay, but you should know how to map or how to rewrite a query involving implicit join to a query involving explicit join. Okay, so the only difference is that in explicit join you use the keyword inner join, and you will have to use the on. On is followed by the join condition. Whereas in the implicit join, it's simply adding one more condition using a where clause. Okay, good. So here we have this, ER diagram. If required, I'll come to this slide. Otherwise, we may not. I just put that in case I would need that in referring during my lecture. And this is the ER diagram. And in this slide, we have the corresponding relations for the ER diagram, which will be mapped to the different tables if needed. So now this is probably going to be one of the toughest query. So let's see what we have here. We want this supplier number. Okay, R. Wait a second. Let's start decoding it from here. Right, from supplier R, that's one table. Purchase order PO is the name given to purchase order. PO line is given the name POL, and product is given the name P. So in fact we have 1, 2, 3 and 4. There are 4 tables, right? So our data our query is complex because we are getting the data from 4 tables. Okay, and we will have 3 joins. So right over here we are doing the joins. Okay, we'll come to that later. Let's figure out what do we need. We saw or we resolved the issue that our source tables are 4 here. Select r.sub_nr. From supplier we need its supplier number. From supplier we need supplier name. From purchase order we need the purchase order number. And from purchase order we need purchase order date. From product we need product number. From product we need product name. From purchase order line we need quantity. Okay, so our requirement is such that we would need all these 4 tables. Luckily we did not require the supplies table. Okay, if the requirement was for price and the delivery period, then yeah, we would have to use the supplies as well. Okay, but anyway, once you know what columns are required, you'll have to figure out in which tables do we have that data. All right, so since our demand is so much, right, that this demand would need 4 tables which we have in the from clause. After that, let's look at the join here. Here we are doing what? Implicit join. Implicit join. It will be a very interesting exercise to write this whole query using explicit join. Please try that. That is an exercise for you. Please try it out. Here, this is an implicit join. Good. So we listed that the table, source table in the from clause. Following that, we have the where clause for join. It says where r dot sub nr is equal to po dot sub nr, and po dot ponr is equal to pol dot ponr, and pol dot ponr is equal to p dot ponr. Okay, so here I know this is complex. Why? Because we have four tables involved. Since there are four tables, we'll have to do three joins, right? So there are three joins, and since there are three joins, we want all these three conditions to be satisfied. Therefore, we will have to use AND operator twice. Okay, let me put some stars here because this is very important, very interesting query, and the result is over here. Fine, let's look at one more query of using join, which is simpler but very interesting. What is happening here? Let me tell you what we want from this query. This query would need the supplier name, okay, who are in the same city. Okay, so that is our intention, and the supplier information will come from supplier table, right? But the issue is that we want two suppliers, not just one supplier. We want the pair of the suppliers who are from the same city. Good. So in this query is important. Again, let me put the stars over here to leave a hint that you must understand this pretty well. This is interesting because although we need two suppliers, the pair of suppliers, but the data is only in one table. Okay, it's a kind of recursive thing. What we need two suppliers who are in the same city. Therefore, we will need two instances of supplier. Right? So let's start from clause. From supplier R1, supplier R2. So we are making two copies of supplier table and referring them with two names, R1 and R2. Alright, that's the reason in the from clause we are saying from supplier R1, supplier R2. We will use two variables for the same table. We need to refer it twice. Okay. Now, if that is the case, what we need? We need r1.subname, r2.subname, r1.subcity. Okay, from supplier R1, supplier R2, where r1.subcity is equal to r2.subcity. Right? So here, the join condition is in fact based on the supplier city. So you need to think about it, right? Most of the times, you might have seen till now, we were joining the table by mapping or equating the primary key with the corresponding foreign key. That is very often the case. But in this interesting case scenario or the query, we want those suppliers from the same city, right? So the joining condition is their city, right? So that's the reason in the where clause, which is our joining statement, where clause, we are using subcity. R1.subcity is equal to R2.subcity. Good? Fine. I hope you followed till this point. The next point is the most interesting one, where we will add another condition. Right? So this condition says where and R1.subnr is less than R2.subnr. Right? Now question arises, fine, everything seemed normal, probably enough. Why did we add another condition? So the answer to that is, if you don't have this condition, it is possible that the same supplier may be listed twice, because the supplier with itself would be listed, right? That's the problem. In order to overcome that same supplier name twice, right, in a pair, we impose this condition that r1.subnr should be less than r2.subnr. Okay, so here is the supplier table. So what I'm trying to say is our join condition is city, right? So New York City. Do we have another supplier with New York City? No, luckily not. Okay, but when you're joining this table, then there will be two copies of this table. You can call one as R1, the other one as R2. Then this daily wise will be paired with itself. Why? Because daily wine's address is New York, and it will pair with itself. Similarly, best wine will pair with best wine. Ad fundum will pair with ad fundum, right? So those are not required. These are not meaningful. We want the pair of the suppliers who are from the same city, but their name is different. Okay, so that thing is enforced using the second condition over here, which says and r1 dot sub nr is not equal is less than r2 dot sub nr. If you put all those conditions, then we will have the actual pair like these two, which are for best wines and the wine depot. Good. And here we have the answer. This combination is correct, like best wines with the wine depot, because they are both from San Francisco. Okay, so let's see. We can also perform more filtration in case of join, as in this example. We want the name of the supplier who's supplying this product with the product number 0899. Okay, so the interesting thing about this query is that we would use the join, which is over here. So you know what, first of all we need to understand that for this query we would need two tables. Why? See, supplier name is available in the supplier table. If we need just the supplier name, we will use the supplier table itself. But this query needs the supplier's name who's supplying the product 0899. So this, in fact, the fact, and we need this thing. Supplier name is coming from suppliers table, but the product information would come from the supplies table. Okay, therefore we must join these two tables. Okay, therefore the data is coming from two tables. Select r dot subname from supplier r, suppliers s, where r dot sub nr is equal to s dot s sub nr, and s dot prod nr is 0899. So the first condition in the where is for join, that is implicit join, whereas the second condition is for filtration. Okay, simple filtration to filter out only the records for the product 0899. Good. Let's see what we have next. Here we want to list the supplier name, right? So it is interesting because we are making use of the distinct keyword. What we want the distinct name of the supplier name who are supplying this product with the product type as rows. Okay, so there are three tables involved because the product type is available in this product type is coming from product table. The supplier name will come from supplier table, but yeah, the relationship between the supplier table and the product table is implemented using another table, which is supplies. Okay, so we would need the data from all these three tables. Therefore, what we do, we will say where s dot sub nr is equal to r dot sub nr, and s dot prod nr is equal to p dot prod nr, and p dot prod type is rows. Okay, interesting query, not very complex, but yes, interesting nonetheless. So the question is, the result that you're looking at over here would be without distinct. If you don't use distinct over here, then that's what you would see. You would find that daily wines is listed three times, whereas the wine depot is printed only one time. The reason is that daily wines has three products with the product type rows. Okay, and we are not interested in having the same supplier number listed more than once. Okay, so for that reason we want a distinct thing, and because of the distinct you would get what we need. Daily wines listed only once. Okay, good. So with the join, right, the inner join, you can also apply this aggregate function. Okay, so let's look at this query. It returns the product number from prod P, PO line, POL. Okay, we are using these two tables. The product table and purchase order line. Product table has been called P and PO line has been called POL. From these two tables, what we need? We need prod NR from P. Select P dot prod NR, P dot prod name, sum of Pol dot quantity. Okay, from product P, POL, uh, PO line POL, where P dot prod NR is equal to POL dot PONR. That is where we are doing the join. This is my J, sorry about that. Join. We are doing join over here. This is implicit join, right? Group by P dot prod NR, right? So that is interesting over here, right? The group by is coming towards the end, but it is extremely important. Why? Because this sum that we are doing here, this sum is being performed on the group. And how is this grouping done? Well, first of all, here we have the join condition. And what join will be doing? Join will create another table, right, with the proper joining done by matching the product NR value from product table and product NR value from PO line. And once you get the join table, on that we are doing what? Grouping on the product number. And once that grouping on the product number is done, then you are computing what? The quantity. Okay, so I think this is a very interesting, slightly complex and important as well. We are combining all the stuff means we are combining the group by, we have the group by here, we have the aggregate function here, we also have a join, right? So kind of what all we learned till now, we combined that together in an interesting query, and that's the result. Okay, so you have product number 0178 with product name and then the sum of the quantity. If you want, you can give it a name also using an as. Outer join, the last topic. Okay, so in the inner join, as you saw, we need the matching rows. If the rows don't match, then the result is not reported. But there is this interesting concept of outer join. Let me read this to explain to you what we do in outer join. Outer join can be used when we want to keep all the tuples of one or both tables in the result of the join, regardless of whether or not they have matching tuples in the other table. Okay, so for inner join, the matching is must. If the two rows from two tables, they don't have a matching values, they won't be reported. Whereas in case of outer joins, it may be required for us to report one complete table with matching or not matching thing. If it is not matching, we will put the null. So I'll show you the example. How do we do that? Well, we will use there are three kinds of outer joins, right? The left outer joins, the right outer join, and full outer join. So let's look at the left outer join. So here, let me read the query and then I'll explain to you what is happening here. We are getting r.sub_nr, r.subname, r.substatus, s.prod nr, s.purchase price from supplier as r left outer join, right? We are using left outer join. I'll tell you what will happen in left outer join. So from supplier as r left outer join, supplies as s on r.sub_nr is equal to s.sub_nr. Right? So if I replace this left outer join with inner join, right, then yeah, the result would be as expected. We will have the matching values from both the tables. But here, since we're doing the left outer join, so we want all the tuples from our left table. Our left table is R, right? So we want all the suppliers information with the supplies, right? Now for some supplier, we may not have any supplies. So in that case, what we'll do, we'll keep the columns from the supplies. These are the two columns, right? Product number and price. We'll leave those as null if that supplier does not have a matching entry in the supplies table. That's an example of the left outer join. Why left outer join? Because we want all the tuples from left outer join to be figured in the result. So look at this. Here we have what? This is the supplier table, right? And then here is the supplies table, and we are doing left outer join. So what will happen? 21. If you look at this, let me see if it will make sense. 21 has these matching, right? Two matching, whereas 68 also has a matching, but 98 doesn't have any matching. Okay, and this is our left. This is your R, this is the S, and we are doing left outer join. So the case of the wine crate is going to be interesting. Why? Because in this picture, as I can see, I don't have a corresponding matching row in the S table. Okay, so let's see what will happen here. For daily wines, we don't have a problem, right? There are matchings available. But for a different example, I think this is not the example from here, 94. 94 is not listed here. But anyway, let's think about 52, the supplier number 52. For supplier number 52, we don't have the information on supply table. Okay, therefore, the supply status is, wait a second, right? Left is R, on the right hand side we have what? Prod NR. Prod NR, because this supply is not providing any product, so prod NR should be null, right? Its status is also null, but this sub status information is coming from the supplier table, right? So let's not worry about this part. We should worry about these two columns. Why? Because these two columns are coming from the supplies table. And since the supplier is probably new, okay, the supplier is new, therefore the entry is only available in supplier table. Supplier is new, did not get any the orders, so in supplies table we don't have any entry. But since this is left outer join, we will keep the supplier with the number 52. Okay, but the values for the right for the columns from the right table will have null there. Okay, it's important, make sure that you understand it. You saw the left outer join, right outer join is just similar. In the right outer join we will keep all the tuples from the right table. Okay, and if we don't have the matching tuples or the rows from left table, then we'll leave those as null. So how do we write that? Here we go. The example is select p.prod nr p.prod name sum of the pol dot quantity. As sum, we are giving it a name from po line as pol. Right outer join. So here, okay, and our right table is p. Okay, so we are doing the outer join from POL, which we are calling as for PO line, we are calling as POL. Right outer join with product as P on POL dot product NR is P dot is equal to P dot prod NR, grouped by P dot prod NR. Okay, so the result would look like this. So P is on our right hand side, right? So that's the reason we are calling is right outer join. And we listed the columns of the writer table earlier. That's the reason we have p.prod nr, p.prod name. But yeah, this the product may not be listed in purchase order line. If that's the case, then this sum would be null. Okay, so here again we are doing the right outer join, where the columns of the right tables are listed even if they don't have the matching rows in the left column, sorry, in the left table. All right, so that is it. Probably it has been a little lengthy lecture. The remaining part of the SQL I will cover in the next coming video lectures. All right. Thank you so much. Bye bye.